very good for anyone that works on SAP security. But specifically talking about network protocols, sometimes SAP security is not very well for not specialist people. Most of the research was performed on the application layer. The learning curve is still steep. I mean, you need to invest a lot of time to start doing SAP security. And sometimes it's not well for penetration tests that are not targeted to SAP systems. So if you are performing a network penetration test in a large company, a large network, sometimes it's difficult to focus on SAP systems. Also, in recent years, it's got a lot of media attention, and sometimes that's not the best thing. So the idea of this work and this talk is to apply a network penetration testing methodology to SAP environments. So the idea of a network penetration testing is that you as a professional sit on a point of a network and start assessing the different components from a security point of view, trying to first discover all the different systems, the different services that are running, gather as much information as you can. Then you continue by assessing the different components, and if you succeed on finding vulnerabilities, you can go on the exploitation phases, upon exploitation, either for keeping access to the systems or for pivoting and accessing another ones. So the idea at some point is to apply this approach on SAP environments. So this talk is about all attacks and some recent and new attacks, and all protocols and new protocols. I exclude almost all the web-related services, so that is not covered. Also, not all the protocols and not all the previous attacks are covered in this talk. And I also want to mention that it's not a penetration testing guide, but most a review of different attacks. So the approach that I took was mostly black box. By black box, I mean that I tried to learn as much as possible from each service, but not by reverse engineering the binaries, but mostly looking at the network traces, looking at the application traces, and trying to understand how each protocol and how each service works, and learning as much as I can. I also rely on a lot of other works. There are a lot of references in the material. I could be missing something, but there's a lot of links and reference to different research and publications. And also, because of the black box approach, it could be not completely accurate. I mean, there could be components that I misunderstand, or things that could be wrong. It's kind of disclaimer. I also use a lot of tools for doing this work. The most important ones are these two tools that I developed in a previous research. PySAP is a Python library for crafting packets in different SAP protocols. It's based on SCAPI, which is a very good Python library for doing that. And one of the best things is that you define the different packets in a declarative way. So it's also good for documenting all the different packets and how each packet looks like. And another tool that I developed, and I use it and improve it a lot for this work, is a plugin for Wireshark that allows you to dissect the different SAP protocols and look in more detail at each part of any packet. So this diagram shows something like a classical SAP environment. In this case, the scope is the NetWeaver application server. in both versions, the application server ABAP, the Java version. These are most of the common services that runs on each application server. And the idea of the talk, is at some point to review some of these services and try to understand the network protocol behind each one and give some details. So I will go through these 5 different services and protocols, starting with the subrouter, then talking about the gateway service, the dispatcher, message server, and enqueue server. So let's start with the first one. The subrouter is an application level gateway. It's commonly used as a reverse proxy. So you can run this service as a standalone application somewhere in your DMC and configure the service to allow or deny access to different internal components. So it's present in almost all the SAP installations. It's kind of exposed on the internet. I mean, the main characteristic is that allows you to expose internal services to the internet, to remote networks. And one of the characteristics is that also is unencrypted by default. So it makes a really interesting target for attacks. So this diagram shows a typical installation where the subrouter is installed in the DMC. It allows or denies access to different network ranges. So there are a lot of well-known attacks against this service and this protocol. One of the most interesting ones are the ones that Mariano Núñez from Napsys showing on his talk at Hack in the Box 2010. And Dave Hadley also made a good review of some of them more recently. But what Mariano showed is that you can, for example, use the subrouter as a proxy for accessing internal services, or you can even scan internal networks using the subrouter is not well configured. So looking in more details about the protocol, it uses 5 different packet types. The administration packets that are used for performing remote administration tasks. When you, for example, with the subrouter program, request a stop or starting or any command, a remote command on the subrouter, the packets are of this type. Looking at the protocol, I found some commands that are not included in the documentation, like that you can set or clear traces for a specific IP address, or you can set traces for a specific connection, and that's just not included in the documentation. I'm not sure why. There are also another packet type which is used for control messages. So this packet is used by the subrouter when it forks its own process, and it's used for control and internal communication between different subrouter instances. And I also found some operation codes that are not included in the documentation, that you can request the version of the subrouter, you can set handles, and there are some operation codes that are used for when the SNMC, the encryption layer, is enabled for the service. The last packet type is a route request. When you need to access to an internal system through the subrouter, you build a packet. When you put a list of all the different hopes you need to reach to get to your target service. It could be also password protected. So some recent attacks against this protocol, well, the most interesting one are the ones that found some researchers from ERP Scan, some peers of Aixig, which is present here, when he found a heap overflow on the route string when the server parses the route string. So this is a really interesting vulnerability because the service is exposed on the internet, and this packet is parsed before any access control list, so any remote attacker can exploit this vulnerability. Obviously, it was already patched in the last year. There's not much information about how to exploit it, but as customer, if you're running SAP system, you must be sure that this patch is installed. So some security measures that you can apply to enforce the security of this service. Well, obviously, to keep up to date on the latest patch, the latest version. Enforce the use of encryption by means of SNMC. Harden your route tables. Be sure that the only entries that are included are the required ones. Put the subrouter behind a firewall. It's not the subrouter is not aimed at using without firewall. So you must be sure that you put a firewall in front of that. And obviously, don't use passwords, because if you don't have encryption enabled, password travels unencrypted. And also, the passwords are stored in plain in the server side, so it's not a good idea. So continue with the next services. The SAP Gateway is the service in charge of handling all the RFC connections. So RFC is a protocol by SAP that you can use for execute a remote function in a remote system. So we have seen a lot of different attacks and different references to RFC calls today and yesterday in the workshop. This service is commonly used for integration between external service and obviously between all the different components in a SAP installation. It's also unencrypted by default, and it's generally exposed more than the SAP network because it's used for interfaces with different systems and, for example, legacy systems and things like that. So this protocol has also a lot of well-known attacks. I don't want to enter into more details about specific attacks. One of the most interesting ones, and the first ones that got published, were the ones from Mariano Núñez also, when he showed that you can gather information on the server side. The service can be configured in a monitor mode, so you can perform remote administrative tasks on the service. Also, man-in-the-middle attacks, sniffing, some old remote code execution issues. You can perform login for brute force attacks, and a lot of different attacks on the modules and the programs receiving the RFC connections. So there's a lot of information available, and I'm sure that it will continue to grow. It will continue to appear new attacks on RFC and different RFC programs. So looking inside at the protocol itself, there are I found at least two different main kind of packets. The main ones, which are the ones used when you request an RFC call, and the monitor packets, which are used for the administration of the service. So one of the interesting things is that almost all the data that travels with the RFC protocol, it's built upon RFC tables. It's built in a table format. So if you look inside at each packet, you will find all the data stored in that format. So some security measures, well, obviously, again, to patch both sides, the client, the RFC initiation communications, but also the server side. Make use of access control list. The gateway can be configured to use different access control lists. Obviously, to disable monitor mode if it's not required. Enforce the use of encryption, and enable and review logs on all the different components. There's an interesting guide from SAP which sum up almost all of these security measures. So going to the next service, the SAP dispatcher and the DIAG protocol. The SAP dispatcher is the service that handles all the communication between the GUI clients and the application servers. The protocol that it uses is called DIAG. It's a very powerful protocol because it can carry embed RFC calls. So, for example, you can, from the GUI, request the execution of an RFC call on the server side, but also from the server side, you can execute modules and programs on the GUI client. So it's very powerful. It's also unencrypted by default, and it's only compressed. So there are also well-known attacks against this protocol, mostly related to the sniffing, login credentials, and the unencrypted nature of the protocol, but also some interesting ones like the ones that Andreas showed in 2011 at Troopers, when he found that you can, for example, modify the program that handles logins and request execution of functions on the GUI clients. So when the clients connects to the server or to modified version of the server, it executes unexpected commands. So it's a really interesting attack also. And some recent attacks, well, I spent some time in 2012 working on this protocol, reversing it and trying to obtain more details. I found that you can gather information on the server side. You can also perform a login brute force by mimicking all the interaction that the GUI client performs when you log into an application server. There are also some interesting attacks like that you can set up a rogue server on the network and send GUI shortcuts. If you entice a user to open that GUI shortcut, you can entice users to access to your own rogue server and, for example, gather credentials or also perform some of the attacks that I recently mentioned on the GUI clients. So it's a really interesting attack vector. I also found some buffer overflow vulnerabilities that are already patched. Are included. The reference information is included on the course advisory. So some security measures: patch both versions and enforce the use of encryption. This is a really important thing, and as a consultant, I often see clients that are still running the service without any encryption. So I think it's an important point. So to continue with the next service, the message server is another service that is present in all the SAP installations. There's only one message server per system, and it handles all the load balancing information for GUI users and RFC users. So when a GUI client wants to connect to an SAP system, it asks which application server is the best one for connecting to. So that information is handled by the message server. And it's also used for internal communications between all the different application servers. So the service exposed in the recent versions 2 TCP ports, one for external users accessing the service, and the other for internal ones, the application servers, and an HTTP service also for all the load balancing information. So it's also an interesting target because all the application servers connect to this service. So well-known attacks, well, the service can be configured also in monitor mode. So you can perform some remote administrative task if the server is configured in that way. There's also well known that you can gather information on the message server and you can impersonate an application server, but I didn't find any good reference or good implementation of these attacks. So one of my goals was to try to get more details and see if I can implement this attack. And there are also some buffer overflows on the HTTP interface, but I think that most of the current installations are already patched. So looking inside the protocol, it's a kind of complex network protocol. It has at least 2 different packet types, the main ones and the ones used for administration, but it has a lot of different operation codes. In administration packets, you have around 16 different operation codes, and most of them uses different packet formats, so you need to understand how each one is built. And there are also around 75 regular operation codes. So some of the interesting things that you can do if you know how to craft packets. For example, you can dump data from the message server, data like the configuration, the release version, and a lot of different information about the clients and the different application servers. You can also monitor the clients accessing the servers, the message server. So you can, for example, connect to the message server and send an operation code to get notified about when an application server connects to that message server. So that's also very useful doing a penetration test, but because you can discover new application servers by connecting to the message server. The service also works as a messenger. I mean, you can send and receive messages to and from any of the clients connected to the service. It's also interesting that you can change some configuration parameters by connecting to the message server. So some recent attacks against this service, well, there were some buffer overflow vulnerabilities released 2 years ago by the Zero-Day Initiative. They were already patched, and they are very good exploits, very good vulnerabilities. When the server parses the change parameters operation codes, so it's really interesting to look from both sides, from a penetration testing side, but also to be sure that the patches are installed. Some recent attacks, well, this one I found along with Francisco Falcon, which is an expert writer from Core Security. We found a memory corruption vulnerability on the message server or on some of the operation codes related to the Java version. Francisco did a very good job at implementing a real attack with the memory corruption issue, because the memory corruption issue only allows you to modify with a lot of restrictions some memory locations, some memory pointers. So he managed to, by sending requests, first enable the monitor mode and give administration privileges to the connection. So that's the first step. Then you can override the change parameter function pointer. So the next step is to send a change parameter request with a proper payload, and it will trigger the function pointer that you overrode on the previous step, and that way you can exploit and have the payload running on the server. So it was a kind of very difficult to exploit vulnerability, but Francisco managed to make something really feasible and that's also available on Core Impacts. All the information about how to exploit the vulnerability is in the advisory with a very good technical analysis from Francisco. So some new and old attacks. Well, I managed to find a way to perform the impersonation attack. There's only one step that I'm missing, which is managing all the load balance information in order to, when Git clients access the message server, they will be pointed to your server and not another one. But it's a really interesting attack Juan Pablo also yesterday showed some details about the same attack being implemented. So it's a very good one. And I will show a demo of the previous vulnerability. But first, I want to show some how this is a Python console. I don't know if you know IPython. It is a kind of interactive interface for Python. So you can type here Python commands and it will be running on another place. But it's very good for showing these kind of things. And for example, I want to show how using the PySAP library you can craft packets of the different protocols. So I want to show, for example, the memory corruption issue and how to exploit it. Well, first we need to perform some setup, like importing the different libraries and different things. Then we need to connect to the server, create a connection. The first step when you connect to the message server is to perform a login. So you need to say that you are logging in to the service. Oops, sorry, that didn't work. So well, the socket got disconnect. Okay. When you connect and you perform the login, the server returns a string that identifies the server. In this case, it's MSG server. This is the packet that you need to send for obtaining a configuration parameter value. So I wanted to show how you can build this in Python with the PySAP library. You specify in this case, the administration operation code and the parameter value, the name of the parameter, and you send the message server packet, including your own name and the target name, the server string as a target. So you send a message directly to the message server, including the administration operation code. In this case, is to obtain the value of configuration parameter, and the response includes the current value of that configuration parameter. So, for example, you can request the change of the parameter using another different administration packet. In this case, the operation code is named AD shard parameter. And you can request the change, for example, in this case, to enable audit, which from an attacker's point of view doesn't make any sense, but you can do the other way around. And in this case, there's an error number telling you that you don't have privileges to change parameters. So what I will be doing in this step is to get the payload that I told Francisco build and send a request to the vulnerable function and exploit the memory corruption issue. In this case, only for enabling the monitor mode. So after that, if you connect again to the message server, you will get a connection that has privileges, and you can, for example, request the change of the MSAdmin parameter. In this case, you will see that there's no error number, so the change of the parameter succeeds. And if you request the actual value, in this case is 1. So I wanted to show this is like very creepy because there's a lot of information, but the idea is that you can craft the packets at this level and send different requests and perform some different administrative tasks on the service. So it's very powerful after you know how to build each packet. So let's continue. To sum up some of the attacks that we saw on the Mesa server, there are different access levels required to perform some of these attacks. For example, if you want to only monitor different clients accessing the service, you only need to reach to the external port of the service. But for example, if you want to impersonate an application server or dump data, you need to access the internal port. As I showed in the change parameter administration task, you need the monitor mode to be enabled. So this is just to wrap up and for the records. But there are different access levels according to what you want to do on the service and which administrative function you want to perform. So also to sum up some security measures you can apply. Well, obviously again to keep up to date on the latest version, to patch all the systems, use ACLs, access control lists in all the different levels, disable the monitor mode. In previous versions of the SAP NetWeaver application server, the internal and the external port were the same, so there's no distinction. There was only one TCP port for both connections, the internal ones and the externals. In new versions is enabled by default this separation, but you as customers you need to be sure that you are configuring your services in that way, and also enable and review all the different logs. So there are also some references there for configure the ACS and separating the internal and external ports. So the last service that I want to show is the enqueue server. The enqueue server is a service that handles all the log mechanism at the application layer. So it handles all the logs of the different tables, but not as a regular database when you can log or you log a table when you need to write, for example, but it's almost the same but on the application layer. So there's only one per system because of the nature of the service. And also in recent versions, you can run this service as a standalone application. So the previous versions, in the previous versions, the enqueue server works as one of the work processes in the central instance, but in the newest versions, you can run the enqueue server as a standalone application. And also you can configure for high availability with a replication server. So this also makes the service an interesting target because there's traffic going on from and to different application servers. So this is a typical configuration of the enqueue server when different application servers connect to one Mesa server and to one enqueue server as a standalone application. And it also has a replication server for providing high availability. So some well-known attacks, where I didn't find any good reference on attacks against this protocol and this service. I also found some security notes, like that there were some crashes if you send some specially crafted packets, and that you can also transfer files between different application services using the enqueue server, but didn't find any additional information. So looking at the protocol, it's also a kind of complex network protocol. It has at least 4 different packet types. The connection administration, when you can change parameters about your own connection to the enqueue server. The server administration, when you can perform some administrative tasks on the server side. All the packets that carries the replication, and also some special packets used for statistics and the application servers knowing the status of the enqueue server log table and things like that. So some security measures for this protocol and this service, also to keep up to date on the patches, on the fixes. And in recent versions, you can also enable access control list. So you must be sure that you are restricting access to the service only to the application servers and not external clients. Enable and review logs, and also restrict as much as you can access to the servers, because I didn't find any reference on how you can configure this with SNMC, and if it's possible to configure to run using encryption. So there's a lot of critical information traveling with this protocol and the log tables, critical from an system operation point of view. So it's also really important to restrict access by means of firewalls or any other additional measure. So to wrap up on the classic SAP environment, we review some attacks on the subrouter, on the gateway, on the dispatcher, the message server, and the queue server, which are the most common and the most important services that are present in the NetWeaver ABAP installations. So let's see a little more about the modern SAP environments. This is kind of picture that I had in my mind about how a modern SAP environment looks like when you have a lot of different clients connecting to the cloud or something else. The classic ones, the SAP Git, browsers for HTTP servers, but also a lot of new API clients, mobile devices, and things like that. I think is the direction that SAP is taking. But if you look inside at the network and at the infrastructure layer, most of the companies are still the same. I mean, you will need a NetWeaver application server running there. So most of the attacks that we saw will be still valid in modern SAP environments. But there are also a lot of new solutions and new products that will be continued to be integrated with the modern different SAP environments. So I want to focus only on the ones that I found more interesting from a security network protocols perspective, which are the NetWeaver Gateway and SAP HANA. So NetWeaver Gateway is a service that is installed as an add-on for the ABAP version of the NetWeaver application servers. It's aimed at integration between different clients, different services. It offers a REST API based on OData and Atom protocols. So the most interesting thing that I found is that these protocols are standardized. There's a lot of information available about the protocols. There are also some tools to perform penetration tests against these protocols implementations. So I think SAP did a good move on using standard protocols. In this case, the OData. So I expect to see a lot of new attacks coming in the following years against this service. And also SAP HANA, which I think is becoming the kind of flagship product of SAP. They are building a lot of different services and solutions around SAP HANA. It's an in-memory database, very well performant, and it's column-based, and it has a lot of features not found on the classic RDBMS. So from the protocol perspective, the thing that I found also really interesting is that they publish all the specifications of the protocol. So that's a very good move from SAP also. In that reference, in that link, you can see how to build all the different network packets. So I also expect to see a lot of different attacks, like the ones that I show in this presentation, targeting the SAP HANA in the following years. So just to starting to wrap up, some information about what we saw and the different phases of a network penetration test. Regarding discovery and information gathering, you can discover services by different means. The key thing is to identify all the different components in a SAP installation. We saw some attacks to gather information on the different services and start to get in as much information as you can. Also, some of the services are authenticated, so you can perform brute force attacks, or most interesting to look at default credentials. And going to the vulnerability assessment and exploitation, we saw some attacks related to sniffing and man-in-the-middle attacks. Almost all of the protocols are unencrypted by default. We also saw that it's very interesting to involve clients and trying to entice clients and perform attacks, taking clients into account. Also, some functions that could be abused, like the monitor mode on the different services, and some of the remote administrative operation codes that the different services provides. We saw also several remote code execution vulnerabilities that are really interesting to look at. And I think that the point of success in a network penetration test is to reach some connection when you have privileges to access to the different components and bypass the different access control lists. And I think with all the different attacks that we saw, if you reach that point, you will probably succeed and own the complete SAP installation. So this is also just for the records, but kind of review of the different attacks that we saw on the different services. I scratched the ones that are really patched and are marked more close to specific vulnerabilities. So some conclusions on the defense side. Well, obviously to test all the different services, to always to do this in a continuous way, to always patch all the different services. It's something like something that we saw. It's complex, it's difficult, but it's one of the main points of performing a penetration test. Also use encryption channels in all the services that you can. Monitor the different logs, and also restrict the ACLs on all the services. So to finishing and to wrap up some conclusions, well, we saw some new and recent attacks affecting the different services. Some of the old attacks can be now practically implemented because we have some information about the protocols. We discussed also some defense and hardening ideas. And the most interesting one for me is that there's more protocols details available for the research community. So I will expect also to see a lot of new attacks and new vulnerabilities being exploited against these different protocols. So I don't have any more, so if anyone has a question.
The parameters that you were able to query, were those only parameters that were related to the message server? Or
yeah. No, to the message server are also the ones that are dynamic. There are some ones that you can change.
So
but
even the parameters that were not related to the message server, like gateway simulation, would be good?
No, that's one you can't change. You can only change the ones that are related to the message server and the ones that are dynamic. There are others that doesn't make any sense to change from a remote point of view. But it's interesting. You can, for example, enable HTTP interface in different ports. You can allow or enable or disable different services of the message server. You can disable auditing. You can do a lot of interesting things, but constrained to the message server. Okay.
Are there more questions? So,
okay.
Thank you, Martin,
Okay, thank you. Well, if I have 5 minutes more, I want to talk a little more, but only 1 minute. The source. Yeah?
I think we have time, yes.
Great. So well, I receive a lot of feedback from different people, and I receive a lot of contribution from different researchers. So the new versions of the tool will bring the new protocols that I review in this talk. Also a lot of new examples and improvements, fixes on different things. I think that there's a lot of room for improvement, but it's growing. I mean, the tools are growing. I still need some work on fixing more things and improving the RFC and the DIAG protocols. I also wanted to add some new protocols like P4 or the network protocol used for HANA. Some more examples and allowing support for different versions. I mean, the different protocols and the network packets changes across different versions, so it's really hard to keep up on all those. I also did some work on trying to improve the service discovery using Nmap. So if anyone wants to use that and test and start improving the probes, the Nmap probes, it's very useful for perform penetration testing and for the discovery phase to have a lot of more proofs and new proofs and test it against different versions and different services. So anyone that can join me in that, I will really appreciate. So that's all.
Thank you very much.
Thank you.